With our proving lines parallel 3-2 notes, most of this is already typed out, so pause me, fill in where you need to fill in with the definitions, and I'll just go through it the way it's presented on here. So we learned about corresponding angles, that they're congruent when the two lines that the transversal cuts is parallel. Same with alternate interior, alternate exterior, and then that same side interior and same side exterior angles were supplementary, so they added up to 180 when a transversal crossed two parallel lines. Today we're going to go, or this set of notes is going to go in the reverse direction. So we call it the converse. If you guys remember what the converse is, that's when we took our conditional and swapped the hypothesis and conclusion. So that's basically what we're doing with these postulates. So the converse of corresponding angles says if two lines and a transversal form corresponding angles that are congruent, then you can assume that the two lines that the transversal cross would be parallel. So in this example, lines L and M would have to be parallel because we're told that these two angles, 1 and 2, which are corresponding angles, are congruent by the little pink mark there. So from that you can distinguish or say that these two lines are in fact parallel. Same with converse of alternate interior angles. If you have two lines cut by a transversal and you have alternate interior angles that are shown congruent, so basically if angles 1 and 2 are congruent, then these two lines would have to be parallel because these angles are alternate interior and they're congruent. And the only time that can happen is if the two lines, in this case L and M, are parallel to each other. Converse of same side interior angles, same thing. If in our same pictures that we were just using, if in that case 2 and 4 are supplementary, because remember same side interior angles are supplementary. So if these two angles are same side interior and they're supplementary, so if they add up to 180, then lines L and M must be parallel because that's the only time that would happen. Again, pause me because you guys have more to write than I do. I figure you would just appreciate not having to read my handwriting. Now, proving the converse of alternate interior angles, you're given that angles 1 and 2 are congruent, and that's shown in the picture as well as stated on the given, and you're asked to just prove that L and M are parallel. So that would be our last reason. And remember, again, corresponding angles are postulates, so we can use that for part of our reason. So on this one, well, we can use the converse of corresponding. I should be a little more specific. So with this, we can't use alternate interior angles, and we can't say that they're congruent because that's what we're asked to, or we can't say alternate interior angles are congruent because we aren't told that they're parallel, even though we have alternate interior angles that are congruent. We can't say it is because of alternate interior angles because we don't have that information, because these postulates are only determined to be either congruent or supplementary if the lines are parallel. So you guys got to think that through a little bit. So the first thing, we can draw our T-chart. A little diagonal going on there. Obviously, we should start with our givens, and you guys really should try and figure this out before listening. Like maybe pause, try and figure it out and see where you guys get stuck, because that's the only way you're really going to build your understanding, is to get stuck and then figure out why. If you never have a question, you'll never learn anything if you just listen to everyone else do it. Alright, so angle 1 congruent to angle 2, because that was given to us right here. We got our statements and our reasons. Now, we know that because it was given. We have to prove lines L and M are parallel. So basically, when you're proving two lines that are cut by a transversal to be parallel, you have to somehow introduce one of the other special angle pairs, show that they are either congruent or supplementary, depending on what pair you introduce, and then say the lines are parallel because of converse of that kind of angle. It will be the same process every single time. It'll just be different variations of the angle pairs. So we have three, and like I told you before, they're giving you this information for a reason. So you somehow need to introduce a relationship between either 1 and 2, or 1 and 3, or 2 and 3. Okay, or it might be both. It all depends. So on this, I can say, a lot of you might think of angle 1 and 3. Okay, 1 and 3 are congruent because of vertical angles. And then I can swap out 3 and 2, or the 1 with the 3. Now I've shown that 3 and 2 are congruent, and 3 and 2 are in corresponding positions. So because 3 and 2 are in corresponding positions, and I just showed that they are in fact congruent, I can use converse of corresponding angles. So that's my plan of action that I'm going to write down. Should always have a plan. So angle 1 and 3 are congruent because they are vertical, the kissy fish angles. And I don't really see a relationship that I can use right now, but I do see two things that are congruent to the same angle 1. So I can put them congruent to each other through substitution. And then check, do these angles have a relationship? Oh, 3 and 2 are corresponding angles. Well, I just showed corresponding angles that are congruent through substitution. So by converse of corresponding, L and M have to be parallel, which is what I'm asked to prove. I'll do a cursive L. So converse, whenever you're proving lines parallel, it will always be converse of, and then a special angle pair. Converse of corresponding angles. Alright, so now on to the next. Which lines, if any, must be parallel if angle 1 and 2 are congruent? Justify your answer with a theorem or a postulate. So if I told you 1 and 2, and this is that number sign again, so we have two sets of possible parallel lines and two transversals. So if 1 and 2 are congruent, and you might have to kind of turn me sideways a little bit so you can see your two parallel lines off on the top and bottom instead of the sides. But basically, I hope that you guys see that those are alternate interior angles. When you guys are trying to figure out who's the transversal, who's the parallel lines, the transversal touches both angles. Okay, they make up a side of both of the angles. The two parallel lines only touch, one parallel line touches each, makes up the opposite side of the angle. So the transversal makes up one side of the angles, one of the parallel lines make up the other side. So in this case, I need to get a highlighter. Let's see what we can do here. In this case right here, let's see if I can make it bigger. Nope, I don't think so. This DE is touching one side of 1, and CK is touching one side of 2, and DK is touching one side of 1 and 2. So do you see how they come together, the transversal and each parallel line, to form the angle? EC over here does not have anything to do with angles 1 and 2. So that definitely would not be involved. So the two parallel lines would be ED and CK. So ED, we make the little double-headed arrow, and CK. or you could say DE, it doesn't matter which order. And the reason being is converse of alternate interior. Remember, it's always the converse of whatever angle relationship they have. In this case, alternate interior. Which lines are parallel if angle 3 is congruent to angle 2? Or which lines are parallel if angle 3, that should be an and symbol, and angle 2 are supplementary. So make this an and sign. Not a congruent, that's a typo. So looking at the same picture, I'm going to try and erase this. Maybe, or not. Because it doesn't want to erase. Oop. Oh, I don't want to erase all that craziness. Oh, but let me erase it, I don't know. Anyways, guys, so which lines are parallel if 3 and 2 are supplementary? So let's take a look at them. Let's switch up my colors here. Here's 3 and 2. So first identify what kind of angle relationship they have, and their same side exterior. So then you can say, okay, what line is touching both of them? And that would be the CK line right here. They make up a side of both angles, so that's my transversal. And EC is touching that angle 3, it's making up the other side. And DK is touching angle 2, it's making up the other side. So the two parallel lines would be EC and DK. And if 3 and 4 were congruent to each other, those are corresponding angles. Here's 3 and here's 4. Since they're in corresponding positions, it would still be the same, ED or EC and DK. They're still touching the same angles and doing the same thing. So this would be converse of corresponding. The other one would be converse of same side exterior. Hold on. Alright, so now we have converse of alternate exterior angles. So you guys are going to have to write a lot here, so make sure you pause it and write everything that you need to. So if two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So same process as all the other ones. So if these two are congruent, then A and B are parallel. Same with same side exterior. So in the same picture, if 1 and 3 are supplementary this time, so if they add up to 180, 1 and 3, since they're in same side exterior positions to each other, that would make A and B parallel. So these would be all reasons that you would use in your proof to prove lines are parallel. You would say converse of same side exterior, converse of alternate exterior angles. So let's prove the converse of alternate exterior angles. So if you're given that 1 and 2 are congruent, they're in alternate exterior positions, prove that A and B are parallel. So start with your T-table, your statements and reasons. You want to start with your given. And then they have angle 4 here, not just to look pretty, but there's a reason for it. You're going to have to introduce that angle 4 with one of the other angle relationships. So 1 and 4 are vertical angles. So we want to write that, so they're congruent to each other. And then because 2 and 4 are both congruent to angle 1, you can say that they're congruent to each other. So this is very similar to the last proof we just did. And that's because of substitution. And then from there, see if you can come up with a relationship between 2 and 4. Their corresponding angles that you just showed were congruent. So now you would have enough information to say A is parallel to B because of converse of corresponding angles. Alright, so I think that's done for proofs. Let's do one of these algebra problems. Find the values for x which make L parallel to M. So if L and M are parallel to each other, then that means that you can use those special angle relationships. So first identify their relationship. Hopefully you're thinking corresponding. And corresponding angles are congruent when the two lines are parallel. So set them equal to each other. And then solve for x. So you're going to subtract 6 from both sides, then divide by 2. So that should give you 17. And they just wanted the value of x, they didn't want the value of the angle, so alright, on to the next one. Notice with this, you have an obtuse angle and an acute angle, so that at least should tell you don't set them equal to each other. So by process of elimination, you guys should add them up and set them equal to 180, because they're same side interior angles. So 7x minus 8 plus 62 equals 180. Combine like terms here, so that will give us 7x. And I'm going to go ahead and subtract it from 180. So 7x would end up equaling 126. Divide by 7, and you get 18. Now remember, all these problems, you guys should be trying to do them before you watch me do it. In this example, find the measure of each angle again. Identify the relationship. We have an obtuse angle and another obtuse angle, so most likely they're going to be equal to each other. And they're alternate interior, so since they're not same side or linear pair, they're definitely equal to each other. So 14 plus 3x equals 5x minus 66. Get the x's on one side, so I'll subtract 3x here. And then add 66 to the other side. So we get 2x equals 80. Divide by 2 and you get 40. So x is 40, but they want the measure of each angle. So plug in the 4 into this x, or the other one, doesn't matter. And when you plug it in, you get 14 plus 3 times 4, which gives you 134 degrees. Which makes sense, it's an obtuse angle, so it definitely should be bigger than 90. Alright, now here's one where you guys might not ever pay attention to parking spaces, but if you got this picture of the guys painting the lines for parking spaces, if two workers are painting lines for angled parking spaces, the first worker paints a line so that the measure of the angle is 60. The second worker paints a line so that the angle 2 is 60. Explain why their lines are most definitely parallel. Well, hopefully, based on everything we just did, if this is 60 and this is 60, those are alternate exterior angles. So the converse of alternate exterior angle says if you have alternate exterior angles that are shown to be congruent, then the lines creating them must be parallel. So you would say alternate and exterior angles converse is the reason why they're definitely parallel. An extension to that, if the second worker uses angle 3, what should measure of angle 3 be for the lines to be parallel? Well, angle 3 is obtuse, so it's got to be the supplement of the 60. So it should be 120. Okay, because angle 3 and angle 1 are same side exterior. So converse of same side exterior. Okay, so there's the assignment that you guys are going to have tomorrow. Don't worry about that tonight. Unless you're not going to be here tomorrow, then you might want to worry about it.